Just looking at exercise 4.7, question 7, deductive proofs involving quadrilaterals. In question 7, there are 4 parts, and each of the proofs in each of the parts will be one of the tests for a parallelogram. Okay, so in this first question, A, we've got that ABCD is a quadrilateral in which the opposite angles are equal. Now, if we've let angle A equal angle C, which both equal alpha, and angle B equals angle D, which are both equal to beta, find the value of alpha plus beta, and then hence show that AB is parallel to DC and that AD is parallel to BC. So all you know is that ABCD is a quadrilateral in which the opposite angles are equal. So you're not allowed to say opposite sides parallel or anything like that. All you know that it is that it is a quadrilateral, and basically probably the only thing you can use is that the angle sum of a quadrilateral is 360 degrees. So let's start with that. So we've got alpha plus beta plus alpha plus beta equals 360 degrees, reason angle sum of quadrilateral. Okay. So we're adding those 4 angles up. So therefore 2 alpha plus 2 beta is 360 degrees, or 2 lots of alpha plus beta is 360, which means that alpha plus beta is 360 divided by 2, which is 180 degrees. So therefore we know that alpha plus beta is 180. Now, for part 2, you have to show that AB is parallel to DC and that AD is parallel to BC. So what I'm going to do my co-interior angle like this. So that's my C for my co-interior. Now, because alpha plus beta is 180, we can say that AB is parallel to DC. Remember, when we're using either alternate or co-interior or corresponding, you use it's these 2 bits of the C for the co-interior that are the parallel lines. So I'm going to go that angle A plus angle D, in this case, so that I know which ones I'm talking about, are equal to alpha plus beta, which is 180, which is 180 degrees, because we've proven it from part 1 that alpha plus beta is 180, but also that angle A and angle D are co-interior angles. Okay, so their position is that they are co-interior angles. Okay, in that C, they form co-interior angles. But they also, in other words, these co-interior angles add up to 180. So I can say, therefore, AB is parallel to DC because the co-interior angles, which are angle A and angle D, add up to 180 degrees. So that is why AB is parallel to DC, because this alpha and beta add up to 180 degrees. Now we have to show that AD is parallel to BC. So this time I form my co-interior this way. Okay, so that's my C, and these will be the parallel lines because alpha plus beta add up to 180. So now I need to state that say angle D plus angle C is equal to beta plus alpha, which is 180 degrees, you know, because alpha plus beta is 180 from part 1. But angle D and angle C are co-interior angles. So therefore, I can say that AD is parallel to BC, reason that the co-interior angles, which are angle D and angle C, add up to 180 degrees, or you can say co-interior angles are supplementary. Okay, so that's question 7a. So basically, what have we just proven? We've proven that AB is parallel to DC. So this is what we've done. We've ended up proving that they're parallel and that AD is parallel to BC. So remember, that's one of the tests. Actually, that's basically the definition of a parallelogram, is that 2 pairs of opposite sides are parallel, or opposite sides are parallel. So we've basically shown the test or the definition for a parallelogram in that question. Now for part B, we're told that ABCD is a quadrilateral in which the opposite sides are equal. Okay, and we have to prove that triangle ABC is congruent to triangle CDA. Now, you can already see you've got two sides equal, and we've also got a common side. So you can prove congruence there quite easily with SSS. So, part 1, in triangle ABC and triangle CDA, we've got that AB equals CD. Given. That's given. Okay. And we've got that BC equals AD. That is also given. And we've got that AC equals AC because it's a common side, or you can just write AC as a common side. So therefore, triangle ABC is congruent to triangle CDA, and the reason is side, side, side. Two triangles congruence, and it says hence show that AB is parallel to DC and that BC is parallel to AD. Now remember, to prove that lines are parallel, you have to prove either alternate angles are equal, corresponding angles are equal, or co-interior angles add up to 180. But it's more than likely going to be alternate. Now we can see we've got the double dash side there and the double dash side here. So the angle, or what you can say is, and I've got single dashes there, I want to see which angle this matches up with. Now this angle with a dot here is opposite the side with the double dash, or I can say it's between the side with the single dash and the triple dash. So here's single dash and triple dash and opposite double dash. These two angles are corresponding angles of congruent triangles. So I can do that. So for part 2, I can say that angle CAD is equal to angle ACB, reason corresponding sides of congruent triangles. But I can also say, but angle CAD is alternate to angle ACB, because if you look, they form a Z. So therefore, BC is parallel to AD, alternate angles are equal. Again, BC is parallel to AD because alternate angles are equal. But BC is parallel to AD because we have these alternate angles, just marking that out. So we've got these alternate angles. Remember, the parallel lines are the ones that form the, the top and the bottom of the Z. Okay, and we also have to show that AB is parallel to DC, so we're going to have to use look for some other alternate angles as well. So if we look here opposite the single dash side, if I mark that with an arc, that this is that angle, or it's between the double dash and the triple dash side, also between the double dash and the triple dash side, or opposite the single dash is that angle there. So these are corresponding angles of congruent triangles, but we can also see that they form a Z. They're alternate. Because they're corresponding angles of congruent triangles, they're equal. Because they are alternate, they are also alternate. Therefore, AB is parallel to CD because those alternate angles are equal. So I can now go that angle BA, so this one up here, BAC. So angle BAC is equal to angle DCA, corresponding angles of congruent triangles, but angle BAC is alternate. Or I can put or and, so and angle BAC is alternate to angle DCA. So therefore, so here I've got, if I do my Z this way, so I can do my Z this way, okay, and those alternate angles are equal. So therefore, AB is parallel to DC, reason alternate angles are equal. Okay, so that's the question 7b. All right. Okay, now for question C, it says that ABCD is a quadrilateral in which AB equals DC and AB is parallel to DC. Now, In other words, one pair of opposite sides are equal and parallel. They've told us that. Okay, so you have to prove that triangle ABC is congruent to triangle CDA for part 1, and then hence show that AD is parallel to BC. So basically, you'll be showing that, I know that this is one of the tests for a parallelogram, but you're going to be basically showing that two pairs of opposite sides are parallel by the time you finish here. So we can say in triangle ABC and triangle CDA, we can see that AB, so in these two triangles we're trying to prove that they're congruent. AB is equal to DC or CD. Reason, that was given. Okay, AB equals DC, it doesn't matter if I write CD. We can also see that AC is common, so I can go AC equals AC, common side. So I've got two sides, so I'm going to put a double dash there. Okay, now I can't say that BC equals AD, that's not given. All I know is that AB equals DC and that AB is parallel to DC. I'm not allowed to say anything else. It just tells me it's a quadrilateral. It doesn't say it's a parallelogram. Okay, so well, I've got parallel sides, so I can do alternate angles. So I can also say that angle BAC is equal to angle DCA. They are alternate angles. Instead of writing on parallel lines, we know the parallel lines are AB and DC, so AB is parallel to DC. So therefore I can see I've got SAS. So therefore triangle ABC is congruent to triangle CDA, and the reason is SAS, side angle side. And now for part B, you have to show that AD is parallel to BC. Now the only way you can really do that would be with alternate angles, okay? To show that alternate angles are equal. There's no other way really. So, well, I'm going to put a little mark here. Now this little mark is opposite the single dash side. This mark here is also opposite the single dash side, this arc. Or I can say the arc is between the side with double dash and no markings. Here, this angle is between the double dash and the side with no markings. So those angles that I've marked there are corresponding angles. So angle DAC is equal to angle BCA. Reason that they are corresponding angles of congruent triangles. And I can say that angle DAC is alternate to angle BCA. Remember, alternate angles just form, you know, they're part of that Z, okay? They're alternate. And they will only be equal if the lines are parallel. And they are equal because we've just shown in this part up here that those angles are equal. And now I'm saying, well, their position is that they're alternate. So I can say, well, therefore, AD is parallel to BC. The reason is that the alternate angles are equal. Okay, so that was very similar to part B. Now for the last question. So basically what we've shown is that this is parallel to this. That's what we've just shown. So basically we've shown that this is a parallelogram because I've got two pairs of opposite sides parallel. Okay, so it's not asking this, but therefore it's a parallelogram because reason is two pairs of opposite sides are parallel. And now for part D. Here I've got the ABCD is a quadrilateral in which the diagonals AC and BD bisect each other. It doesn't say bisect each other at right angles, just says bisect each other, okay? So in other words, DP equals BP and AP equals PC. So you have to prove that triangle APB is congruent to triangle CPD. So that looks okay. You've got two sides. You can also see that you've got vertically opposite, okay? You can pause the video and just finish that off yourself, and when you're done, just turn it on and check, okay? So in triangle APB and triangle CPD, we can see what we've got. We've got that AP equals CP or PC. Reason, BD bisects AC, and we can see that BP equals DP. Reason, why does that equal that? Because AC bisects BD. Now, if you think you're going to get that wrong, sorry, pages moved. If you think you might get that wrong, you can just put diagonals bisect each other, okay? But we also can see vertically opposite. So angle APB is equal to, so APB equals angle CPD. Reason, vertically opposite angles. So therefore, triangle APB is congruent to triangle CPD. And we can see we've got SAS. Now for part 2, hence show that AB equals DC and that AB is parallel to DC. So we're I know that this has got parallel symbols on it, but it wasn't meant to. Okay, so you're supposed to prove that it's parallel. So I'm just going to get those off there at the moment. You weren't supposed to know that yet, because it just says that ABCD is a quadrilateral in which the diagonals bisect each other at P. That's all you were supposed to be given. You are to prove that the triangles are congruent using that information. That's just a mistake on the question. Okay, now part B, or part 2, show that AB equals DC. Well, we can see we've got congruent triangles. So now I'm going to say that AB is equal to DC. Reason, corresponding or matching sides of congruent triangles. And they're asking us to prove that AB is parallel to DC. Well, you can only do that with alternate angles. So I can either do this angle here, this dot is opposite the single side, or between the triple side and the double dash side. Between triple dash and double dash, I've got the single dot, or, sorry, I shouldn't put dot because I've got a dot there. I'm going to put it as a cross. Cross and cross. Okay, so the cross here is opposite the single side, the cross is opposite the single side, or between the triple dash and the double dash. Between the double dash and the triple dash is the cross. I can say angle PDC is equal to angle PBA. No, not that they're equal, angle, PD, that doesn't even look like a D, so angle PDC, or I can go PDB, might be easier for you. So angle, I'll just fix that all up, 1 minute. Okay, I'm actually not going to start from P, I'm going to go angle CD, angle CDB, or even CDP, it doesn't matter. So angle CDB and angle, so CDB and angle ABD are alternate angles. And I can say that angle CDB is equal to angle ABD. Those angles are equal because they are corresponding angles of similar triangles, you know, from part 1, because we proved that these two triangles are congruent. So that cross is opposite the single dash side, and this cross is also opposite the single dash side. So I've basically shown that they are in an alternate position, those angles, and that those angles are equal. So therefore I can say that AB is parallel to DC, and the reason is that alternate angles are equal. Okay, and the alternate angles are ABP and CDP, that those alternate angles are equal. Okay, that